Welcome back! In the last episode we created our Ventoy install medium, and today we are gonna use it. We will install Arch Linux on the Beelink from scratch. The video is long because there will be theory segments in which I teach you the basic concepts. These sections are optional. I will still guide you step by step, but I highly encourage you to watch them. Remember that things are getting ugly on the internet, and knowing how your stuff works is a great asset to fight back. Also remember to take notes. I keep lots of notes, and for this purpose I recommend Obsidian, an amazing tool for taking and organizing notes. Well, let's get you on the way, here, in Corbin's workshop. Alright, let's connect the Beelink device. So, power cable goes right here. It's this one. And the other side goes to your outlet, which is behind my screen. There we go. Next is the display. This is the HDMI cable for my display. The device has two ports. Just set it there. And lastly, we need a keyboard. This is a common USB keyboard. We have 3 ports back, put there. Hey guys, this is Corbin from the future, reminding you to not be like me and please connect some internet to your device. That's all. And that's gonna be it for it. Now, this is our Ventoy USB stick. Oh wait, let me show you how to put it first. Okay, power button should be enough. And it boots with Windows 11. I don't remember my password, I did it just in a hurry. So I'm not gonna log into this. I wanted it for Linux anyways. And don't worry, I learned that the Windows license is embedded on the firmware of the motherboard. So if you change your mind eventually, you can just install Windows again and it's gonna be activated immediately. So, now we are going to connect our Ventoy USB. We are going to restart. Spam the delete key to ensure that you enter the BIOS or UEFI, whatever this thing has. And here we are. And the point here is to go to the boot order and ensure that the USB is first. This is the order in which the system is gonna try to find a bootable record. And this might be in a different order. For example, maybe network is first or whatever. So you gotta make sure that the first option is your USB. USB first, then Windows. And we're gonna save and exit. And now we are booting from the Ventoy USB. And here you have the 4 images we downloaded and installed on the USB stick. And that's it for the setup. I am going to switch to the Beelink display using my capture card so you can see better what's going on. And I'll see you there. Alright, here we are. So the last time I was showing you the boot menu of the Beelink EQ14, and I was telling you that the important part was to go to the boot menu and ensure that the first option is your USB device, so we can boot from it. Confirming that that is the case, we will save and exit and continue. And here we are in the Ventoy menu. These are the images we recorded the last time. And we are ready to begin with the Arch Linux installation. And I just wanted to show you guys that I have here a way to switch between my personal computer and the Beelink view for what's required. Here right now I have opened my step-by-step guide on how to install Arch Linux from scratch. Now, this document used to be a lot shorter because it only had general directions, general instructions, and is what I wrote when I installed Arch Linux for the first time. While I was looking at it to do it again for this guide, I decided to do some changes. I removed parts that I did that were redundant. I was very new into this back then. But I also added step-by-step commands so that I can share this file with you guys and you can keep it for future reference or follow along with this video. That's also fine. Give me a second. Where did I put my water? All right. With that being said, let's begin. We just select Arch Linux and press enter. Normal mode. And we select install medium. And we give it a bit of time. And that's it. It's ready. Now, first step is to prepare our drives. We are going to partition our drives, we are going to format our drives, and we are going to mount them so they are accessible. Great. What does this all mean? Let's talk about partitioning drives. It's like those city management games. You have to mark your residential, commercial, industrial zones before things are built. In a similar fashion, you can't write data on a drive until it has been partitioned. Partitioning can be as simple as one huge partition covering the entire drive, and such is the case for most external storage. But there are use cases that call for more. If you look at our Ventoy USB stick, you will see it has two partitions. A tiny one containing the Ventoy system, and a big one in which you store your system images. This is done so you cannot accidentally ruin the Ventoy drive by manipulating your images. My partitioning scheme on my personal computer is, on the other hand, somewhat complex. Let me show you. This here is gparted. It's a graphical interface for managing your partitions. And what you see on screen is a USB stick I use for installing drivers on Windows. As I mentioned before, this is one case in which a single partition is taking the entire drive, because the main point of the drive is just store data. There is a tiny bit of unallocated space at the end, but that's something that sometimes happens, it's not on purpose. And in contrast, here we have my Ventoy USB stick that we created earlier in the guide. You will see it has two partitions. One little partition with the system itself, and a second partition that takes the rest of the drive, that is where you store your images. If we go to this one, this is my secondary solid-state drive, and it's also divided by half in two partitions. Both are ext4 because I use them on Linux, and the reason why I divided this is because on the first half I installed some games, and the second half is reserved for Unreal Engine stuff and other projects. It's more for productivity stuff. Now let's check on my main SSD. This one is a bootable drive, and so it starts with an EFI partition where the boot information is, and I also created a small partition where my system files are. This is where I installed Linux. I have a small partition for my home folders for my users, and the rest is taken by storage space that I use mainly for games. Now, other than that, this one, for example, is where I have Windows installed. It's bootable, so it also has an EFI partition. And here is the funny thing. All of this space from the second to this space here was completely unallocated. During the Windows install, I just clicked here and told the system install here, and it created this mess of partitions. It created this 16 megabytes reserve partition for whatever reason. It created the main partition, which I labeled Win, it's of NTFS file system. It created this other partition that I don't know what the purpose is, and it left some space unallocated. After that space, I created my Windows games folder in case I had games that don't run on Linux, but I haven't had to use this yet. It's just for emergencies, I guess. And here I have some hard drive space for Linux. Oh, by the way, I forgot to say, this one is a hard drive, not a solid state. And those are some examples of different partitions you can have. This is a hard drive that is partitioned exactly like my secondary solid state drive. And you get the idea. There are many ways in which you can partition your drives. How complex your partitioning will be depends on your experience and use case. The more you use your system, the more you will get a hang of what would be useful to you. For your first system, I recommend to use a single partition on your main drive. Don't concern yourself with the complexities of partitioning, and especially do not copy the partition scheme of my main system. It relies on some trickery to work that would be probably very confusing to explain now. With that being said, let's continue. Alright, with that being said, let's proceed with the partitioning. Give me my keyboard, please. And let's start CG disk. Oh, well, wait. We need to see our blocks. Let's see what do we have here. Let's talk a little bit about storage devices now. Linux has this philosophy in which everything is a file. So even your hardware has a file somewhere to represent it and potentially interact with it. They are usually found in the /dev directory, and you can see a list of your storage devices with the lsblk command. Storage devices in this directory have names depending on their type. SATA and USB drives will be SDX, where X is a letter like you see on Windows, SDA, SDB, and so on. Then partitions in those devices are numbered, like SDA1, SDA2, and so on. NVMe solid-state drives nomenclature I don't understand fully. They are things like NVMe X N1, where X is an assigned number instead of a letter, and then N1 seems to always be N1. So that's that. And for partitions, they are addressed with PX at the end, where X is a number, like NVMe 0N1P1 would be the first partition. Whew, that's a mouthful. In any case, let's continue. Just merely by the size, we are gonna have to identify what's going on here. And it seems like SDA is my Ventoy USB, and NVMe, of course, is the NVMe SSD of this thing. So we are going to run cgdisk on /dev/NVMe 0N1. And these are the partitions we have. We have an FE system partition, we have all this crap that Windows creates, and we are going to delete everything. Yep. Delete, 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 and delete. All right. So now we have pure free space. Now, keep in mind, this is not written yet. You can quit and cancel everything we have done so far. So we are going to create a new one. And as I said, the first partition, since this drive is going to be the system drive, it needs to be able to boot. And for that, it requires an EFI partition. And the EFI partition has to be the first partition on the disk. So I am going to give it about 200 megabytes. And the code is, let's press L to list all the codes. And these are the types of partitions that we can use. The ones that we care about right now are near the top. 8300 is Linux file system. And around the middle, there is EF00. Are you? The code we need is EF00. That's for the EFI system. And for a name, I am going to just call it EFI. And that's it. We have our EFI system partition with 200 megabytes. And I am going to use a single partition for everything in this disk. I am not going to complicate it. I don't need different users. The sole purpose for this device is to store game servers. So I don't need to do anything special to it. Let's just take new, starting. By default, it will try to grab all the remaining space, so we can just press enter. The code is all right like that. It's 8300, which is Linux file system. And we are gonna give it a name. And I guess I am just going to call it Arch. And that's it. There's a tiny bit of space before and after, but you can leave that as is. It's not gonna hurt anyone. And now to finish, you write the changes. Yes, write them, please. And it's done. Windows is dead. We can get out of here and we can type clear to erase everything on the screen. And now it's time to format these partitions we just made. Formatting. Formatting is to create a file system on a given partition. The logic to read and write data on it. You can see it as building a foundation and basic infrastructure on your plot of land. There are many file systems, but the important ones that matter to us right now are FAT32, which is very compatible but very limited, NTFS, which is for Microsoft stuff, ext4, which is the main Linux file system, and exFAT, the most common external storage file system. You can also use FAT32 for external storage, but limitations like the 4GB file size might be inconvenient for you. There are other popular file systems for Linux, such as Btrfs, but I don't really trust Btrfs, so I go with the all-reliable ext4, which, unlike Btrfs, has never given me a problem, and some of the advantages Btrfs provides don't do much for me anyways. Logical volumes are overhyped. I have changed my partitions like once in 5 years, and it wasn't even necessary. And for backups, I use timeshift. So for me, Btrfs is meh. In Linux we use mkfs to format partitions, which stands for make file system. You use it by typing mkfs dot and the file system, followed by options and the target device path. Kinda like this. So now, let's keep going. And for that we use mkfs, which stands for make file system. The EFI partition needs to be FAT32 specifically. So we type -F32. And we need the path to the device. So sorry, we are first going to double check. And the EFI partition is clearly the 200 megabytes one. Is going to be the NVMe 0N1P1. So make file system FAT-F32, and it's going to be /dev/NVMe 0N1P1. And that's it. That fast. And now for the other one, it's going to be mkfs x4. X4 is the basic Linux partition file system. There are others like Btrfs that some people like. I do not trust that one, so I am gonna go with the classic ext4. It does a great job already. So that's gonna be NVMe 0N1P2. And that is done. And it's that simple. We have our partitions and they are formatted. That's all we need. Now we need to mount them into somewhere on the system so we can use them. Let's change directory to the root of our virtual system. CD stands for change directory. So here we are. This system we have here exists only in memory. It's the one we use to boot this device, and we have to choose somewhere to mount our new partitions. So what does mounting devices mean? So, mounting a drive is to connect a file system to a point in another file system. It sounds complicated, but not really. Windows already does this for you automatically. When your Windows system boots, it detects your connected storage devices and mounts them to default mount points with assigned letters. You have seen this: C, D, E, and so on. And when you connect external storage, it does exactly the same. You have to remember to unmount them before you unplug them though. On Linux, the experience varies. Desktop environments like Plasma behave a lot like Windows. But if you are setting up a system from scratch, like we do on this guide, you have to do the mounting yourself. For this, we use the mount command. It takes a device path, like we talked before, and a directory in your system. Yes, that is correct. You can mount drives anywhere you want. Well, as long as you have the proper permissions, that is. You want to mount a hard drive on your documents folder? Go ahead. There are some nuances to this command when using file systems like NTFS or FAT32, but they are not going to be relevant to this guide. We will use the plain mount command. And if you want your drives to be mounted on startup, you need to create a file system table file, or fstab, which resides on the etc folder. Don't worry, I will guide you through all of this, and it's going to be quick and painless, I promise. So, let's get to it. Let's list our devices. Alright, so we are going to mount /dev/nvme 0n1p2, that's going to be the main one, onto nnt. And we are going to mount p1 on mnt/efi. Sorry, I forgot to add //mkdir, so it creates the directory if it doesn't exist. Bam, that's it. If we check the directories, there they are, and if we check our devices, you will see that our new partitions now have mount points in /mount and mount EFI respectively. So they are mounted now, and we now need to create a file system table so that the system knows to load them immediately upon startup. So we are going to create a folder, mnt etc. etc is a folder in Linux file systems that contains all of the system configuration. That's why we created, that's where our file system table should go. And we are going to run hen fstab -u on /mnt, and this prints our detected file systems, and we can confirm that they are correct. We have UIDs, we have the mount points, we have the file system for each, and a bunch of flags. So we're going to run it again, but this time we are going to redirect it to a file. Output redirection is when you take the output from a command and send it to a file instead of the screen. If you use one arrow, the output will overwrite the file if it already exists. Using two arrows will append the output to the file instead. There are other advanced things you can do, like sending standard output one way and errors the other way, or flat out ignoring errors. But that's a topic for another day. For now, I just wanted to clarify how are we going to create our fstab file. Here is an example of it in action. If I list the files here, in this folder I only have this script I just created. And if we check the script, all it does is it prints a message to the screen. So let's leave this. So if I execute it, bam, it prints something to the screen. But if I execute it and redirect to a file, if I list again, you can see there is a new file here. And if I check the file, we see that the contents of the file is the output of the command. That's all redirection is. It's really easy. It's going to be /etc/fstab. And if we list our etc directory, we can see that the file system table is already there. Alright, so the next step is to install the base packages. And for that we use backstrap-i, we select our system mount point, and we choose the packages. It's going to be base and base devel. Go. And we are gonna go with IP tables standard, and that's a bunch of packages, and we choose yes. And we give it some time. While it does that, we can review our instructions. We are here preparing the base system. Once it's done with this, we are going to switch into our new system using chroot. And it's done. Wow, that was relatively quick. Alright, so we installed a bunch of packages, and now we are going to do this. arch/chroot, and we select our mount point. And here we are. Technically, we are now in our system. Alright. And we proceed with our installation. Now, this is interesting. Hold on a second. We are now in the main installation. We need to choose a text editor. We are going to need it to change some configurations. If you are a beginner, I recommend you use Nano. If you're more advanced, if you know what you're doing, or you want to see a tutorial beforehand, you can use NeoBeam. This is my favorite text editor, but it takes a while to get used to. It's definitely non-conventional. So maybe you would like to go with Nano. I am going to go with NeoBeam. And we go back to the Beelink, and that's what I'm gonna do. Oh, by the way, this is the first really important command that you should learn. Pacman stands for Package Manager. It's the most important tool to learn. It's the main way to install and remove programs and libraries in Arch. Each distro has their own package manager, and it works in a similar fashion. It's such a practical way to manage programs that even Mac and Windows have their own version of the concept in things like Brew or Chocolatey. Its usage is very simple, but it might take some time to remember the usual options. So, here's a few of the important ones. Pacman-S, which will install a package given a name. Pacman-SS, and notice how this is case sensitive. It lists packages matching the word given. Pacman-RNS removes a package along with dependencies that are no longer needed and configs. Pacman-SY updates package database. pacman-su updates all installed packages, and pacman-syu is a combination of the above. This is the most used. And pacman-scc. It clears all cache. Pacman keeps a storage of previous versions of packages in case of emergency. This can take a lot of space over a long time, so every so often, when it's safe, clear the cache. And those are the essentials of pacman. Let's proceed. Alright, so back here, we are going to use the package manager /s to install NeoBeam. Yes, please. And that's it. I now have a text editor. It's that simple. Installing applications in Linux is normally that simple. Now, I am going to use my new text editor to modify the configuration of the package manager. nvim. I told you that the system configuration is in etc, and the configuration for the package manager is pacman.conf. And here we are. A few changes I want to do to this is add some color to the output of the package manager. So this is another interesting topic. The lines that start with hash symbol are considered comments and are ignored by the system. So that's what I did here. I removed the hash so that the option is enabled. And I need to find the repos and enable the multilib repo, this one. Multilib, yes please, both lines, and that's done. Right, so I save the file and I quit. Clear the screen. Okay, we have modified our package manager, and now we are going to get into the good stuff. We are going to install the Linux kernel. Just like the previous iteration, we use pacman/s Linux, the Linux headers, and optionally you can install other kernels. There are multiple kernels and there is no drawback to having several. You can choose which one to start with each time you start your system. So I'm going to install a couple of additional kernels. Linux LTS is the long-term support. It's a more stable version. It's a little older than the regular one, but it can save you. For example, back when I was starting my Linux journey, when I got my Alder Lake processor, it turns out that on Linux, the combination of the Alder Lake and my NVIDIA card had severe issues. And while I found how to fix it, I started my system with the LTS kernel that didn't have the problem with the standard kernel. So for me, it has only been one time, but that one time it saved me. So it's good to be prepared. So I suggest you install the LTS. And the one I use now on a regular basis is called Linux Zen. A few years back, there was a lot of talk about custom kernels. Some people swear by it, some people say that the difference is not really noticeable. But in any case, well, I like to use the Linux Zen kernel. So we are going to install the Linux Zen kernel. So 6 packages. Oh, my bad. When we enable the new repo, the multilib repo, we had to update the repo database. I didn't do that. So So we are going to do it now, and that's fine. And now we can surely install our kernels. Yes, option 1. Yes, please. And another batch of waiting. Look at them go. And with that, our kernels are installed. Now, we're going to install another related package, and it's gonna be the Linux firmware. This is a collection of drivers of all kinds. If you see here, when I press enter, you will see that there are several packages of different companies. So technically, I guess you can choose the ones you think you're gonna need or not. And the truth is that it's too little space. What, 350 megabytes? I think it's worth it to just install all, and that way whichever driver you are gonna need is probably gonna be there. So let's just go with everything. And that's it. Installation of the firmware is complete. Next step, we are going to set the locale, and for that we are going to use remember, I am using NeoBeam to edit my files. If you chose nano, you would be doing nano /etc blah blah blah. Just a reminder. NeoBeam /etc/ locale. And here I need to find the locale I want, and it's gonna be in US. You have to search for your locale, and just remember that you need the UTF-8 one of whatever language you are using. So that's gonna be it for me. Just one. And now that I have edited that one, I need to run locale gen. And it will generate the language I chose. And now I need to create a new file, nvim /etc/ locale.conf. And here we need to insert a variable called lang equals, and mine was nus.utf/8. I think that is correct, and I will just simply save my game. Save my file, and that's it. Now we need to do some setup for our users. We are going to set up the root password. The command is simply password, and my new root password that I will change later. Right now I will take something simple just to not drag too much the introduction. It's gonna be like that. Okay, so now root has a password. And after that, I am going to add a new user because it's not good practice to be using root for everything. And for that, we use user add -m to create the home folder. And we give it a group. He's going to be part of the users group. And as additional group, I am going to give it the wheel group. Wheel is sort of the administration group. It's used for the sudo command that I will introduce a little later. And this user is going to be called echo. And that's it. And now we need to give echo a password. We use the same command, password, but with the name echo. And the password for echo is going to be something a little more complicated. This is the one I'm going to be using, and there is echo with a password now. So our users are set, and now I need to give administration their permissions. So for that, we are going to do editor nvim is the one I am using, and the command bsudo. What this does is a special mode to edit the sudo file, because it's such an important file that headphones are driving me crazy. So this sudo file is so critically important that one typo can absolutely break the administrator's privileges. So we need to enter in this special mode. And here we are. And what we need to find is a line that gives all these permissions, and it's right here, this one that says wheel all equals all, to give the wheel users all of the permissions. And that should be all right, and we should be safe to save the file. And that's it. Our administration permissions are set. Now, we are going to start with the bootloader. We are close to booting the system for the first time. For this, we need to install a few more packages. We are going to install grub. We are going to install fe boot manager. We are going to install DOS file system tools. Tip: if you were to install Linux on a system that has other operating systems like Windows, you would need a tool called OS Prober. It is really important, but for this device, it's gonna be Linux only and this Linux only. So I am not going to install the OS Prober. And then we're going to install mtools. Yes, please install everything. That is really quick. And now it's time to actually install the bootloader. So what I was saying, if you were to install this alongside Windows, you would have installed the OS Prober, and you will have to edit the etc default group file, and near the end there is this line right here that is disable OS Prober false. You would need to uncomment this to enable the OS Prober. I'm not gonna do it because I didn't even install it. Okay, so we continue. We now have to do group install // target. It's gonna be x86 64 because it's 64 bits, and oh wait, I forgot, you have to specify -EFI, and after that it's dash bootloader. I mean, wow, I didn't really think that my position was gonna be so uncomfortable. That's making me type so badly. So bootloader ID is going to be Arch. You can name it whatever you want. And finally, the EFI directory is going to be /EFI, the folder we created near the beginning. So those three options, I think that is correct. Okay, let's list EFI, and there it is, it's correct. And finally, let's generate the configuration. Group mkconfig -output. And this is gonna go into /boot /grub.cfg. And done. Our bootloader is complete. It should be ready to reboot into our new system. But first, let's install some network tools. pacman/s, and we are gonna install net control, WPA supplicant for wireless, and wireless tools, and the network manager. For this, systemd is correct. We go. And our network tools are installed. And let's now enable systemctl. Is another important command. Is what controls the services in our system. So we are going to do systemctl enable network manager. It is case sensitive, so it has to be like this. And with that, the network manager is going to be enabled when you start the system. Now, if you want the system to be remotely accessed, if you want to control this computer from somewhere else, and in this case I do want this for this device, we need to install SSH. SSH stands for Secure Shell. It's used to establish an encrypted connection with another device and log in remotely. This allows you to use the terminal to operate the device pretty much as if you had physical access to it. For this to work, a device needs to start its SSH daemon to be ready to receive connections. In Arch, you can do this with systemctl. Systemctl is the tool for systemd-based distros to manage services. There are a few very important systemctl commands you need to remember. ctl start starts a service once. Systemctl stop stops a running service. Systemctl enable makes the service to start each time the computer boots, and systemctl disable makes the service to no longer start on each boot of the system. And there's also systemctl status, which shows the status of the service. On the Beelink, I will enable the SSHD service, so it's always available. But in your personal computer, you might not want to enable the SSHD service, or maybe just start it when you need to do something. It's completely up to you, and whether you need to access your personal computer remotely or not. In my personal computer, I only start the SSHD service when I need it, which is usually to copy files. So that's about this. Let's continue. So we are going to install pacman-s open SSH. Yes, please. SSH means secure shell, and it allows you to start a session to a remote system. So that way, I will be able to log into this device from my personal computer and do my stuff that way. I don't have to connect a keyboard into the Beelink anymore. That's gonna be very convenient. Now, after SSH is installed, we need to change some configuration. And beam /etc/ssh/sshd-config. Ports are like the facilities for shipping and receiving data packets in your device. A connection is always established at a specific port of the given address. They are numbered from 0 to 65,535. So, there's a lot of them. Ports under 1024, however, are standardized with designated purposes and you should not use them for custom things. For example, here are a few of them. This means that, for example, when you attempt an SSH connection without specifying a port, the program will assume the connection will happen at port 22. You can, however, choose a custom port for your connections in most programs. You will see in the guide that I will set up the SSH daemon with a custom port. Also, whenever you have to specify an address and port for a connection, you do so by using a colon, like so. I want first to change the port. We're going to enable this line and I'm going to change it to a different port. Port 22 is the standard SSH port. I want it somewhere else, just to confuse my enemies if they are scanning my ports. And that's it. Now, to be fair, it is not that important to change this here because this is only on the internal network. It's gonna be really difficult that someone tries to hack my Beelink device from within my network. This is something better done at the router level, but we are gonna see router configuration in a later video. For now, just for the lulz, I want to change the port. You can leave it at 22 if you want. It's really not gonna be important. And that is it. And now we have to enable SSH, systemctl, enable SSHD. SSH daemon is the SSH server basically. And that's it, our SSH is enabled. And with this, I think we are ready to reboot into the system. I want to reboot into the system before continuing because I want to load the network manager and everything else. So we are going to exit the chroot command we did earlier, and we have to unmount the partitions we mounted, which were mount EFI and mount. And let's check our devices. Yes, corrected, please. Okay. And we can see that nothing is mounted anymore. So we are safe to restart the computer. Shutdown-R now. And after I press enter, I am going to remove the USB so that we boot finally from the Beelink itself. Let's see if everything works now. And here we are booting from the Beelink for the first time. This ugly menu is our system that is ready to use. Basically, at this point, you can say that you installed Arch. It's that simple. Now, if you start with this one, it's gonna start with the default kernel, but you can go into advanced settings, and here is where you can choose which kernel you want to start with. And you can choose anytime you restart your computer. That's what I say, there is no harm in having several kernels. So I am gonna start with the default one, Arch Linux with Linux. And we are asked for a login, and we are gonna log in as echo with my password, and that's it. This is finally our system. My home folder is empty, but here we are. We are finally into our freshly installed Arch Linux. So, now that we have started, I want to set a host name. Now, we are not root anymore. We are echo in this case. So every time we want to do something as an administrator, we have to type sudo before the command. This is like asking to have our permissions elevated for this command. So sudo hostnamectl hostname, and I'm going to choose a new name for this. I will change it later, but for now I will just call it Beelink. It asks for my password, and that's it. The command worked. So if you see the command prompt here, it says echo at Arch Linux. I'm going to exit and log in again, and see, it says now Beelink login. I'm going to log in as echo again. And that's it. We are logged in as echo on the Beelink. How about that? All right. So now we are going to continue setting up the SSH. We can check the status of our services like this, and we see that SSH is active. Now, let's type IP addr so we can see the IP address of this device. Wow, we have several connections. Interesting. But the important one is the number 3 one. You can see that it says inet 192.168.172. That's the IP address for this device. What is an IP address? I'm glad you asked. Let's talk about IP addresses. Just like in real life, people need addresses to send packages to each other, so do computers. Each device on your network and the internet has an IP address. I want to make the clarification that we will be talking about Internet Protocol version 4. Version 6 is a whole other beast that you won't have to worry about too much for a while. So IPv4 addresses. They are formed by 4 numbers separated by dots, like this. And before we continue, I have to make sure you know how binary works. Our numeric system is called decimal because it uses 10 digits, 0 to 9. And the way it works is that when counting, you write them in sequence, you run out of digits, you start over and increase the next digit by 1. We have the convention to not write zeros to the left, but technically they exist, so I write them for demonstration. Binary works exactly the same, but it only has 2 digits, 0 and 1. Therefore, the carryover happens much sooner. In digital systems, a single value of 0 or 1 is called a bit. A group of 8 bits is a byte, and the maximum number that can be represented with a byte is 255. You surely hear this word all the time. It's the basic unit of information. Byte, kilobyte, megabyte, gigabyte, terabyte, etc. But going back to IPv4 addresses, each of these numbers is a byte. The range for each one goes from 0 to 255. And since each byte has 8 bits, each of these numbers is also called an octet. Sometimes you will see a slash and a number after the address. That is the subnet mask. Let's talk about subnets since it's important. An IP address usually has 2 portions, the subnet and the device. In the previous example, the /24 tells us that the first 24 bits, or the 3 first numbers, designate the network, and what remains, which in this case is a single number, designates the device. What this means is that 192.168.10 is the network, and the network can hold 255 addresses, from 1 to 255. Well, actually 254 devices, because the last one is the broadcast address, and you should not assign it. This example is really simple because 24 is a multiple of 8, so it fits perfectly. But some configurations will need you to do some calculations. Let's not get into that. Knowing how subnetting works can be very useful, because if you need 2 devices to communicate with each other, they must be within the same subnet range. This can help you diagnose problems in your home network if 2 devices are not seeing each other, or it can even help you customize your home network. Imagine, for example, that you can make a subnet for guests that allows them to connect to the internet, but they can't see your home devices, for example. There's a whole lot that can be done with this. So, each device in your home network has an IP address, usually something like 192.168.1x, since this is the default range for private networks. But there are other ranges used, like 172.16xx. In addition to this, your router will have a public IP address, which is the one the world can see and access. It's critically important that you don't share your public address with strangers. That is like doxing yourself. This is why I say it's a bad idea to host public services on your home network. Giving away your public address will open you to attack. If you must host something public at home, my advice is to buy an extra internet connection from your provider, with its own cable, router, etc., and host there, with no connection to your home devices. And with this said, let us proceed. So now we know what an IP address is. Let's put it to good use. Here I am in my personal computer again. And first things first, let's see if we can reach the Beelink device. We know that it's 192.168.172. And yes, in only 3 milliseconds, our data packets arrived to the Beelink. So now we are going to try to log into the Beelink. Our custom port that we configured, and we will log in with our username at 192.168.172. Okay, authenticity of the host. Yes, we will add a fingerprint. And it asks for our password. And that's it. I am echo at Beelink now. And if you can see, it it is even white. It's not the pretty blue of my usual prompt. And if I do like this, I can see this thing, or I can use nbeam /etc/ fstab, and I can see my file system table that I created earlier. And I have full control of the Beelink from my personal computer. At this point, I no longer need a keyboard or a display on the Beelink. I can control everything from here if I want. Isn't that cool? Alright. We can leave the Beelink with exit, and we are back to our system. It informs us that the connection to that address is closed now. And that's pretty much it. Oh, hold on. Let's do something cool. Let's move on our view to the Beelink again, and ls, we are at our home, and we are going to create a new text file called hello, and we're going to type hello intruder, get the hell out of here. And we are going to save it. All right. Let's clear our screen. And back on the personal computer, let's connect again to the Beelink. We give our password again. And we can ls, and there is the hello file. I can check it out. Hello intruder, get the hell out. And I will say, nah. I'm going to save it, and we're gonna leave the connection. And if we go back to the Beelink, we can check the file, and it's modified. Isn't that cool? So that's how SSH works. Let's do one more thing. So here we have my Android tablet with Bluetooth keyboard and Termux installed, which is a sort of Linux environment for the tablet. And let's try ping 192.168.172. And we can successfully ping into the Beelink device. So the next step is going to be SSH-p, our custom port, echo at 192.168.172. Yes, please. And I add my password. And voila, I am connected to the Beelink from my tablet. And we can prove that by going for the hello file. And here it is. I'm going to say I'm snooping from the tablet. And we can just save and quit. And let's exit. So we are back at the Beelink. And we can check the hello file. And we have the text we typed through the tablet. And that's it. Oops. Undo that. And that's it. All of our devices can connect to the Beelink using SSH. Now, for the next demonstration, the firewall. What is the firewall? I'm glad you asked. The firewall is the first line of defense of your devices. I like to use Papers, Please to illustrate. The firewall itself is this here. Imagine a bunch of security checkpoints at your device's borders, and they are tasked with approving or denying every packet of data that reaches the checkpoint. And in our case, NFTable's configuration files are like the bulletins that inform the checkpoints of any new policies for access. These files looks kinda like this, and I will explain a little more about them in a moment. Let's continue. So, let's set up the firewall. We only need to install NFTables. Sudo, please. Yes. We install this thing. So, the way this works, let's sudo, don't forget, check the file that it gives you by default. Same as before, all the lines that start with the hash symbol are called comments. These are completely ignored by the system and are only for you to read. For example, this one tells you this is a simple and safe firewall rule set, and it tells you where to get more information. But it has other uses. Since these lines are ignored by the system, you can use it to temporarily disable code. For example, I can come here and place a hash, and this line will be ignored. That way, you don't have to delete it permanently, and you won't forget it. Anytime you change your mind, you can come here and delete the hash, and it will be enabled again. So this is true for all of these lines, except for this one at the top. The hash and exclamation mark is called a shebang, and it's a directive that tells the system what interpreter to use to process this file. When I saw this file for the first time, I was surprised, because usually here it references some shell, either bash, CSH, or whatever. But here I saw that you can put other things as well. Now, onto the script itself. The first thing it does is destroy a table for inet called filter, which is the same one we are creating here. The reason for this is that when you load one of these files, it will usually take the new rules on top of the previous ones. It's like the bulletins in Papers, Please. When you get a bulletin, it usually has new rules that you have to apply in addition to the previous ones. So this file doesn't want that. This file is going to destroy the previous table and start from scratch. Then we have a chain. Input is just a name, it can be named whatever. What's important is the second line. Type filter, we're not going to get into that, but the hook is what's important. During the packet processing, there are several points at which you can insert a chain of evaluation. Each of those points is a hook. In this case, it's tied to the input hook, which means that this chain is going to affect all incoming packets. And the priority is a number. The lower the number, the higher in the priority, the sooner the chain is going to be applied. Filter, I think, is equivalent to 0, so max priority. Then it's the policy. This is the default action that will be taken on packets that survive the entire chain. So the three valid actions are accept, that lets the packet goes through, reject, that denies the packet and notifies the sender that the packet was denied, and drop, that denies the packet silently without telling anything to anyone. Then we have a series of conditions. If the connection state is invalid, we're going to drop it. That's self-explanatory. If the connection state is established or related, we're going to accept it. When you send a request to a server and get a response back, the connection will become established. So what this means is that when that happens, whatever traffic happens back and forth, we are not going to mess with it. It's just going to go through. Now, in interface identifier, low is for the loopback. The loopback is an internal controller that manages connections within the same system. Some applications rely on this, and that's why we are going to accept it. Then is the ICMP. This protocol includes many management and testing and debugging tools like ping that we used earlier. If you were to deny it, we wouldn't be able to use ping. Sometimes at the router level, it makes sense to deny these types of packets because it prevents external individuals from prodding your router and gathering information. But now we are in the internal network. The only person that's gonna use this kind of thing is probably you. Maybe someone in your family, but no one to be worried about. Next line is the same but for IPv6. And the next line is interesting. This is going to accept connections on the SSH port. We are going to be using SSH, but here when it says SSH, it's assuming the standard SSH port, which is 22. But we set SSH at a different port, so we need to change this to our custom port. And that's it. The next one is just a rate limiter to avoid spam connections. And then a counter. It will count all the packets that come through this chain in case you are debugging or something. Finally, we have a second chain, a forward chain. Forwarding is when you receive a connection and you redirect it elsewhere, like a router or VPN or whatever. And this device is not going to be doing any of that. So for now, we are going to leave it as it's recommended, and we are going to drop all forwarding requests. And that's the entirety of the file. I will link in the description a playlist with an excellent tutorial that goes way more in depth of the things you can do with NF tables. And I think we are ready to proceed. What am I even doing here? Aha! I realized I didn't save my file. .nft, and I need to do it with sudo that I always forget for some reason. All right. Oh, I did save. Never mind. In any case, the important thing is that I am going to cancel this line anyways, so we can do some testing with the firewall. Okay, and let's save that. Flush rule set. It's an FD, I forgot, sorry. Okay, this is just to be sure that we are starting clean. So let's move for a second to my personal computer. And let's try to SSH into the Beelink. And we can, no problem. We can see that the hello file is there. Let's exit now. Now let's load the file. To load the file, we are going to do sudo nft-f and let's direct it to the file. NF tables. Okay, and to verify that it is loaded, we can use nft list rule set. I didn't type NFT. Okay, here we have it. And we can see that our allowance for the SSH is not here because we commented out. So since we are dropping everything and we didn't do the SSH exception, our connection from my personal computer should fail. Let's try that. Let's try to SSH again. And we are told that we cannot root to the host. The firewall is working. Now let's edit the file again. Sorry, I'm lazy. And let's allow connections to the SSH port. And let's reload the file. Let's check the rule set. And we can see that our connection to the TCP is there. So let's go back to my personal computer. And let's connect again. And we can see that again we can connect. And that's it. Okay. So now we have confirmation that the firewall is in effect and it's dropping all connections except for ICMP and SSH. Simple. That's how simple it is to configure a firewall. Of course, this is a very basic firewall file. You can go really crazy and do some really complex processing for different things. And I will leave in the description a link to a playlist from a guy that gives a very complete guide of NF tables, even with some examples of some advanced maneuvers you can do, like counting connection attempts, and if someone tries to connect 3 times in a minute, you can ban that connection from an entire day or something like that. Really cool stuff. So, what is next? Our firewall is set. The next step is setting up swap space. And there is a lot of debate on how much swap you may or may not need. This chart here is from the Red Hat documentation. And on my personal computer, in which I have 32 gigabytes of RAM, I don't even use swap at all. So what swap does is that when your RAM is full and it needs to allocate more, it will move some of the least used information in RAM to a place in the hard drive as a temporary storage to free memory for what it needs at that time. So if you have a lot of RAM, like 32 in my case, you don't really need to be swapping. Now, when you have very little memory, like the Raspberry is going to have 4 gigabytes, then I am going to allocate some swap. But I think that even for the Beelink with 16 gigabytes of RAM, I am not going to use swap at all. So we are going to revisit this section when we are working with the Raspberry. And we are going to the final touches now. Let's go back to the Beelink here, and we are going to use time, date, CTL, and I think I need sudo for this. Space set time zone. And in my case, it's going to be Mexico/general. That's time zone for me. Now, sudo time, date, CTL. Set local RTC. Now, what this means is that time on your system can be based on UTC or it can be on local time. Windows loves using local time, which causes all kinds of trouble for other software. Linux usually works in global time, in UTC. So this computer is not going to be using Windows, doesn't care. So we are going to set local time to false. Date CTL. Set NTP. This is using your network to automatically update your time. So it's always correct. So I'm going to set that to true. And that's it for the time. Now we need to edit our hosts file, sudo npm/etc hosts. So this is where you can assign names to IP addresses. For example, by default, you have localhost at 127.0.0.1, and we're going to add a new one, 0.1.1. It's very similar, and this should be linked to your host name. In this case, it's Beelink. Now, I have never personally used this IP address, but this is recommended in the Arch Wiki because some applications need it. So we are just going to do it because of that. And finally, depending on your CPU, there is a package called microcode. There is one for Intel and one for AMD, and it's a sort of firmware update for your CPU. So the Beelink, this one in particular, came with an Intel CPU. So we are going to install that package, Intel-ucode. I forgot sudo again. Yes, please. And we wait for it to finish. I'm just realizing until now that my environment is kind of noisy today. Sorry, but it's been kind of hot and I haven't tested my headset. I am not using my desk microphone because I need the space for the Beelink and all that crap. So I'm using my wireless headset, which I don't use very often. So in any case, the microcode is installed, and to finish, we're going to install a few very useful tools. It's gonna be btop, lf, links, and git. And I'm gonna explain each of these in a moment. Now let's take a quick look at the tools we just installed, starting with btop. Btop is a task manager, like in Windows. You can see at the top right we have the CPU usage per core, temperature and everything, and the GPU usage as well. To the left we have the memory, use, available, cached, free. Then there is the drives, and to the right we have the processes. And you can come to any one of these and you can just kill it. And it even has a feature to search for problematic processes to kill. And that's pretty much. It's pretty easy to use. Then I installed LF. LF is a file manager that you have seen me use in my personal computer. Very straightforward, and it makes navigating the file system a lot easier than spamming CD all the time. Here you can see the file we have been toying around with earlier. Then I installed Git and links. Git is a version control system. It's an incredibly powerful tool. We could make a whole tutorial on it. And I think if you have never heard of it, if you work in any kind of project, you should take a look at Git. For now, we are only going to use it to download a program straight from the repo. Lastly, we installed Lynx. Lynx is a text-based web browser. It's super clunky, but it can save you from time to time. For example, right now we are going to use it to find the instructions to download the last tool I want to show you today. So we're going to go links.duckduckgo.com. It's taking a little bit of time, I see. Well, don't know why, but here we are. So we go to the search bar and we type AUR GitHub. And let's search. Okay, and here we have it. So J is an AUR helper. The AUR is a repository of packages maintained by the community. With Pacman, you manage the official packages, but sometimes the programs you want are not gonna be there. One example of that is Brave. And when that happens, you can take a look at the user maintained packages. For that, we use Yay. So let's go to the GitHub page for Yay. It's asking for cookies, and no, I do not accept. And we search for the word clone, and here we have it. The second one, the part where it says if you don't want to compile, we're gonna get the JBean repository. So we are going to Control C out of here, and we are gonna do that. Let's mkdir repos and cd repos, and here we are going to execute that. It's gonna be git clone https /aur.archlinux.org/jbean.git. And it's cloned. We type ls, we see that we have a new folder, and we need to enter this folder and type make package -si. Hold on. Make package -si. And it's working. My password. Yes, please. And that's it. Yay should be working in the system. So this is what I was talking about. For example, the case of Brave, the Brave browser. If we search for Brave using Pacman, we're not gonna find it. It's not in the official repositories. But if we use Yay, there it is. So another thing that I forgot telling you is that when you search packages, you will see the repository it belongs to slash the name of the package. So for example, here we have a bunch that belong to the AUR, and we have one from extra, which is a Python add block. And then the last one is the actual Brave from the AUR, which is actually out of date, curiously enough. But in any case, this is it. When you don't find stuff in Pacman, you can try J. J has exclusive access to these packages marked as AUR. You have to be careful when you use the AUR because it's maintained by users like you and me. So there has been cases in which malware has made their way into some of these packages. In a later video, I will try to show you how you can mitigate this risk. But for now, you should be fine if you stick to really well-known packages like Brave. Try to not download very obscure packages from the AUR. The other distinction I wanted to make is that here you have two different Brave packages. You have Brave and Brave Bean. The Brave one takes the project straight from the repo. That means it's going to take the source code and it's going to download a bunch of dependencies and it's going to take time building the whole thing. It's rather inconvenient. Usually you only do this if you need something very specific from the very latest version. Otherwise, you should always try to get the package that is -bean. Bean stands for binary. It's a precompiled package and you just download and use. You don't have to worry about anything else. Phew, well, that was something. And there it is. Our device is already ready. It has network, it has firewall, SSH, we have some basic tools, and we have even access to the AUR. The Beelink is ready to work. In the next videos, I am going to install Arch in other devices. I will install it in a virtual machine, simulating a normal computer environment. It will have graphical interface and all that good stuff. Then we will go for the Raspberry Pi. And once it's set in all three devices, we are going to start installing the real tools we need. The services, Sorry, my headset went off. In any case, then we will start installing the real tools. I hope this wasn't too tedious. I hope you learned something valuable and see you the next time.